Saxon Algebra 1/2, lesson 84. I don't know how much you guys even care what the name of the lesson is, but this one is just kind of a grab bag of a few simple ideas, and John lists like 4 different ideas for the lesson name, and I don't like any of them. So I called it addition rule. It is what it is. This is just a lesson that cannot be named. Here's one idea. This is something that confuses a lot of students who are at the place that you are, and that drives me crazy because it's such a simple idea that it seems hard. Okay, let's compare adding with a negative number to subtracting, okay? So let's say 4 plus minus 1, right? That's adding a negative number. We start with 4. We're on the ladder in the meadow. We're on positive 4, so we're 4 steps up above the ground. I hope you don't get heights. What's it called? I hope you're not afraid of heights. Excuse me, I'm not, although sometimes I can't say what it is. And then we go down 1 step. So we would be at 3, right? We added a negative number. Now let's compare that to just saying 4 minus 1. Well, 4 minus 1, you know from like what, 2nd grade, probably earlier, that 4 minus 1 is 3. This is the same concept. Adding a negative number is the same as subtracting, okay? So what that means is that in the world of algebra, we usually add negative numbers. Rather than subtract. And again, don't let this fry your brain. Don't go, what? We don't subtract in algebra? Well, yeah, we add negative numbers. It's the same thing. It's 2 ways of looking at the same thing. So we'll see this over and over and over again. Don't let it flip you out. Just remember that adding with a negative number is the same as subtracting. All right, now John is acting like this is a new idea, what I'm going to show you in a minute. I believe I've been showing you this all along, and so you're going to be in great shape. John is now saying, hey, when we have something like x plus 5 equals 7, and we want to solve that, there's a very specific way we want to format this problem. That's not a newsflash to you because I've been doing it that way all along. What this lesson is an opportunity for you to realize that the way we show our work is super important. I know that you're all getting better at, you're all doing a great job of showing your work. Some of you came by it naturally. Some of you, Joel, had to work hard to get there. But I think you guys are all in a good place right now of showing your work. This is just a reminder that it is a really big deal in algebra to show your work a certain way. And here's why. If you can follow the steps as they're written, it's going to help your brain remember what to do, okay? The way we write down the steps helps us flow from one idea to the next to the next. So it helps your brain if you have a really strong sense of how this needs to look on your paper. It's going to help you remember the steps, okay? Here we see x is chilling with plus 5. He's being added to 5. We want him by himself. That's the first thing we think of when we see an equation is we say, okay, where's the variable? I want him by himself. I want to get all the numbers away from him so that he's by himself on one side of the equation. So what's happening to him? He is being added to 5. Well, we're not having that. That's going to have to be reversed, right? We want to get rid of that 5. We want to, some people think of it as canceling it out. Some people think of sending it to the other side. There's lots of different ways you can kind of mentally look at this, but we want the x by itself. Plus 5, the opposite of adding, is subtracting. or you can think of it as we're adding a negative number. But the important thing is we want to do it to both sides. Look how I showed that. I didn't put an equal sign in between them, but I made the same change on both sides of the equal sign. That is important. Now, you don't have to put the arrow there, but you always just look to make sure you're balanced across, right? If you want to put an arrow there, you can. Now watch what I do. I slash that out gently. I don't erase it. I don't scribble it out hard so no one can ever see it again in the history of the world. I just put a simple slash through it to show, look, it cancels. Then I go x equals 2. Notice how I made the columns go down. There's a method to all of my madness. I'm not going to sit here and give you a 30-minute lesson by explaining everything. Just trust me, you want to maintain those columns. Final answer is boxed, and you put whatever your symbol is once you check it. You don't know, but I glance in the book and make sure I have the right answer before I put the smiley face. And that's what you do, right? You get an answer and then you immediately check it and put whatever your mark is. Okay, beautiful. There is an example of how to do a really super easy problem, right? So let's try some that are a little more involved. 2x plus 1/2 equals 3/4. All right, we've got fractions here. Later, you guys, I'm going to make your lives so happy. We're going to learn that whenever we have fractions and problems, we're going to get rid of the denominators. That's going to start being our first step later on. All right, so for now, we have to deal with them. But just remember, the day is going to come when we never have to face another fraction past the first step again. All right, there's our x. You can circle it or underline it. I do think it's a good idea to mark that to yourself because that helps you figure out what to do first. Here, we've got it being multiplied by a 2 and a plus 1/2. Dang, how do we know which one to do? Oh, this is my corny story about the three-way friendship groups, right? Where two friends are always better. They're not better friends necessarily, but they usually 2 out of the 3 just have like a tighter bond. So these are the ones with the tighter bond. So this is the friend that leaves first. The reason I tell you the stories, you guys, is to help you remember what to do. Okay, so when you see this, I want you to go, oh, it's the 3 best friends, right? Okay, this is the one that's a little bit separate because it's not as close to the x. The 2 is right there clinging onto that x for dear life, right? This one's a little separate, so we send that one away first. Now, this looks really good. It's this format. The problem is we have to adjust the fractions because the denominators have to match in order to subtract or add the negative number. So we look at what these two, what's the lowest? Least common multiple, the 4. So this one needs to be adjusted. Going to be 2 over 4. I like to do this. I like to just rewrite it over here so I can see what I'm doing. And I just put the arrow to show I don't have to adjust it. I am subtracting, so I'm going to add my minus sign right there. 3/4 minus 2/4 is 1/4. And I'm not done yet, though, because I still have 2x, right? Now, I want to divide by 2, but before I write it down, I start to think of this, right? And then I go, divided by 2. No, that's a nightmare. I'm not going to divide a fraction by 2. No. So we think, all right, well, what else can we do? How can we make that 2 go away without dividing it? Because it's being multiplied. Oh, with multiplication, you always have another option. And that is to remember the reciprocal trick. Okay? So when you see that train wreck coming and you think, I have to divide a fraction, stop and rethink and remember your reciprocal trick. So now I'm going to multiply both sides. I'm going to write the 1/2 here because it's a little crowded on this side. This will cancel. Again, notice just a single line, nothing too dramatic. X equals, and then 1/2 times 1/4 is 1/8. I brought this in a little bit, but my equal sign stays right here. Again, there's a method to my madness. I'll explain as we go, but just trust me. You want to keep straight columns as much as you can. I check it in the book. Yay. All right. This rule that we've been using is called, you can call it the addition rule for equations, or you can call it the subtraction rule for equations. It's really the same rule. It's addition slash subtraction. But the idea is that we can subtract or add numbers with equations as long as we do the same thing to both sides. It's perfectly fine to add or subtract both things as long as it's the same side. And then we used what we call the multiplication or division rule here, which is you can multiply or divide. Dividing is allowed if it doesn't create a giant mess. As long as you're multiplying both sides by the same thing, and P.S., we don't want to use 0, because if we try to divide by 0, that's a big problem. So when we talk about the multiplication division rule, we can't multiply everything by 0 or divide everything by 0. That doesn't work. With adding or subtracting, if you wanted to add or subtract 0, you could. It wouldn't do you any good. It would be kind of a waste of algebra, but it's allowed. Okay, moving on to the third problem. .3. Solve. Okay, again, when we first look at a problem, the very first thing we need to do is say, what the heck am I supposed to do? We look for our variable. There he is. Now, there's only one thing happening to him. He's being multiplied by -3. So we don't have to worry about the best friends thing because we don't have 3. There aren't 3 of us. There's just 2. So it's time for this guy to go home. We divide. Now we hold our breath because last time John got us with the don't use division when you have a fraction rule. But here we're fine. There's no fractions lingering. So we feel perfectly fine doing this. That cancels. X equals, and now we had a lesson on this week, didn't we? How do you simplify that? Oh, 2 negatives make a positive, so our final answer is going to be a positive, and we do the numbers first, so it's +4. Notice that when I divide, I don't draw one big line across the whole thing like I did when I added. Remember how I drew the whole line when I was adding? When we divide, we just show the division separately. Kind of like multiplication's a little bit different too. This bothered me terribly when I first started doing algebra because I wanted to draw a big line, but don't do that. It's just messy and it doesn't look, this is fine. This is the way you want to do it. This is the way the world shows division in algebra. All right. In case you have not gotten the memo, these are rules that, these formatting rules are rules that I believe in 100%, and the world of mathematicians and algebra connoisseurs, we all agree exactly on how this should be. So I'm not just making it up. It's not just me, but I will tell you that I believe heart and soul that this is the right way to do it. So I'm not just telling you rules that I don't believe in. These make a ton of sense and they're going to serve you well in the future. A little disclosure from my upcoming autobiography. I am not necessarily a person who follows rules blindly. I'm happy to follow rules if they make sense to me. And I'm talking about rules in the world. I'm happy to stop at red traffic lights because you can't just have a bunch of cars driving around and everybody making up their own rules. We all have to agree on when we can stop, when we should stop, and when we can go. And I think the traffic lights and the stop signs are a really great way to do that. I follow those rules. There are other rules in this world that I'm not convinced are the greatest thing in the world, like send your kids to public school. That I decided was a rule I didn't want to follow. That's why I homeschooled my kids. So I don't necessarily just fall into line when someone tells me there's a rule. I have to test it out and believe it for myself. And if I were you, I would be thinking, I don't know if I just want to fall in line and follow these rules on how you format these problems. What I'm telling you is there are really good reasons for it. So please trust me, and you'll see as we go that this is great stuff. Okay, let me show you another problem. By the way, these all say solve. That's the instruction on all of them. All right. So here we have this problem. We have to figure out how to solve it. Don't worry about negatives and positives or what the numbers are doing. Just start by going, okay, where's my x? Right there. He needs to be by himself. How am I going to unravel this mess? Okay, 3 different symbols here means it's the three-way BFF thing. This one goes home first. We do the opposite of whatever's here. If this was minus, I would add. Because it's positive, I will subtract. And I do it to both sides. And now this time I draw the full line across. I cancel. You guys, I think you know Natalie Smith, the youngest of the 3 Smith girls that were a part of your group for a long time. Their dad worked at Westgate. They recently ended up all moving to Texas. Natalie was obsessed. I taught all of them math too. Natalie was obsessed with this cross out. And if I ever like overlooked it or didn't do it right away, she would be like, let me borrow your pen. Because we would do this in person. Back in the days before COVID, you know, back in the good old days. And she would have to cross it out immediately because she couldn't stand not to cross those out. Okay, minus 3x. Notice I went straight down. 10 minus 4 is 6. Put the equal sign back in. All right, now I divide by minus 3. Again, I don't let that minus sign freak me out. It's fine. Again, I don't make my line go all the way across. I just do 2 separate fractions. This cancels. X equals 6 divided by 3 is 2. I see 1 minus sign. There it goes. That is my final answer. Now this one I didn't line up perfectly. That's not my favorite, but you know, I wouldn't copy it over. Okay, beautiful. All right, the last part of this lesson I find somewhat annoying, but it's really easy, but I just want to show you in the book. John gives us 4 different fancy terms. Additive property of equality, subtraction, no, it's addition, not additive. Subtraction property of equality, multiplication property of equality, division property of equality. Okay, we get the picture. There are 4 properties and there's 1 for each operation. Fine. Why does it have to be so complicated? I don't know. If A equals B, then A plus C equals B plus C. Okay, so what he's saying here is if 2 things are equal, then you can add the same thing to both of them. That makes sense. We were just doing that. If A equals B, then A minus C equals B minus C. Okay, you can subtract from both sides. And look, he's doing the same thing. Here it is, he multiplies both sides, and here it is, he divides both sides. But he says if C is not equal to 0. Okay? So it is fair to multiply both sides by 0, but we don't want to divide by 0. All right, these we've already been practicing. Here they are just written out in fancy fussy language. And in these problems, John says, which property of equality do we use in solving this little thing? All right, well, without doing the work of it, we just look at it and go, okay, well, what would we want to do? We want x by itself. Here we're subtracting 4, so we would want to add 4, right? That would be our next step, is to add 4. So that's the answer John's looking for, is the addition property. Okay? Since we want to add 4, it's the addition property. So easy, right? And here's one that asks you to do that too. This is not a real big deal to me. We're going to talk more about this, the rules of algebra. We're tapping into 2 of the 3 rules of algebra, but I don't want to talk to you about that yet. I just want you to focus in this lesson on being super neat and clean in the way you format your work. I've lectured you enough. Your ears are probably burning from all of my ranting. But, you know, you got that sneak peek into the chapter of my autobiography on how I'm not a rule follower. I live pretty dangerously, you guys, but I do stop at red lights. Okay, I'm done now. Goodbye.